Welcome to this session on creating spaces from a three-dimensional point grid. So in the last session, we created this single floor of guest room modules, basically using a two-dimensional point grid. We're now going to modify that to create a three-dimensional point grid. So I'm going to go back to that ArcGR2 node that we created, and I'm just going to change this input. So initially, we simply used the first arc in our list of arcs that establish each floor to create the arcs that are used for the guest room modules. So now I'm going to modify that. I don't want to use all the arcs because I'm going to treat the two penthouse floors differently. What I want is to use just the guest room floors, these that we established here. So what I want to add here is a count that gets us just the guest room floors, excluding the penthouse floors. There's probably several ways I could do this. One would be to simply use the count of the guest room forms. So I could use that form GR and then use my dot operator and start typing in count and select it from the list there. So we're using the count of these forms, and that will give us the correct number. So I'm going to apply that, and we'll close that. Now you may notice what happened here. What we actually have now is points along the first arc and then points along that back arc, but now it's up at the second floor. So the reason for that is something that we call replication style. If you notice on our ArcGR node, we now are inputting a list for the arcs. So we have about 5 or 6 arcs here at our guest room floors. And then we also put in a list for the distance, the offset distance. So we basically have two lists that need to interact with each other. So essentially there's two ways those could interact, what we call replication style. So the first method would be parallel or corresponding indexing, meaning that to make these lists interact, it takes the first member of this list and interacts with the first member of the distance list, meaning our first arc gets offset 5 feet. Then it would take the second member of this list, which would be the second arc up here, and it would get offset the second distance in this list, which would be that overall width of the building. And then once it runs out of members in any list, it stops. And since we only had two distances, it runs out of members and it stops. So essentially, we only got two arcs, one at the first floor and one at the second floor. But what we wanted was arcs at every floor at all the distances. So that replication style would be called all combinations. So each member of each list interacts with the members of the other list. And so to switch that, this is what this little icon indicates. You can see that the replication style is parallel. If I right click on my node, I can switch the replication style. We can see that that icon has changed. And you notice now we have all the arcs at each floor, which means we then in turn get points at each floor, which in turn means we get polygons created at each floor. So with that simple change, we've now created those guest room modules at every floor, or every guest room floor. So let's go ahead and record that change. Now the only thing we haven't created is guest room modules at our penthouse floor, which has a different width, and perhaps we'll want to create a different module. But the process would be the same. So I'm going to take all of the arcs we created here. We won't need the number. So using your control key, you can select multiple nodes. Then I'll right click on one of them and select copy. I'm going to just come down here and select paste. Paste those right there. Now I'm going to rename these so that we know these belong to the penthouse. So instead of GR, I'm just going to use PH. So this will be point pH and polygon pH. And it'll be the pH area. And the only thing we need to change here is, again, that arc that we're going to offset initially. Open this up again. So rather than the first guest room arcs, we actually want the last guest room arcs. So I'm going to substitute first with last. And then we might do the same thing, except use the count on the form pH on the penthouse forms. And that will give us the correct floors. So I'm going to apply that. And you'll see we now have guest rooms at the 2 penthouse floors. However, you might notice that the width is going out beyond our form, and that's because we used that variable width, and in fact we made the penthouse width different. So what we might actually want to do is again use our form pH, and that has an output of its own width. That way, if we go back and we adjust the width of the penthouse form, it will automatically update the spaces as well. So I'm going to select Apply, and you can see we now have the correct width on those polygons, which should then, in fact, give us a different area on our penthouse polygons as opposed to our guest room polygons. So let's go ahead and record those changes. Now, what if up on those penthouse floors you actually wanted larger rooms, a larger module? Well, we could actually perhaps adjust our number of guest rooms so that we had fewer rooms, therefore larger rooms, up on the penthouse floors. And so, for instance, back where I put in the number of equally spaced bays on the points for the penthouse, I could, for instance, divide that by 2. That means rather than, for instance, 12 rooms, I would now get 6. So I'm going to enter that in. So you can see it better here in the 3D. Now we've got fewer modules, but larger modules. We now have a module that's 755 on our penthouse floor. And I'm going to go ahead and record that transaction. So we have these polygons that represent the guest room modules, and we can get the area of those modules. But for a true BIM model, we might actually want to put building designer spaces where we could track more data about those guest rooms. And so we can easily convert those polygons into spaces using the space node. So I'm going to go back to the node types, and under my building designer nodes, I'm going to drag and drop the space node onto the graph. I'm going to rename this as space GR. And for my technique, I'm just going to use from polygon. Now, on any building designer node, we need to select a catalog item, the data group catalog item, and that's just a pick list. So it's going to default to the space catalog, and then I can select from among my spaces on the space catalog. For now, I'm just going to use this example residential. And then I'm just going to link to the polygon. So we'll link that up to the polygon GR. Now, because of the data on these spaces, these do take a minute to generate. I'm going to show you how to kind of defer their update so it doesn't slow your model down. And you can see now we have space tags on each of those spaces, giving us the actual area. Now, if I right-click on that space node, I have different options here. I can defer the dynamics. I can also defer the update, which means I can work in the model, I can make changes. The spaces won't update until I actually do an update model. That way I'm not slowing the model down as I'm working in it, and I simply update when I'm ready. So I'm going to set that to deferred update, and we'll go ahead and record that transaction. And I'm just going to copy that node and paste it. And we'll do the same for the penthouse spaces. But of course, I want to link that to the penthouse polygons. And now I already had that deferred update on that node. I'm going to come up to the update model on my ribbon, and that will then generate the spaces for the penthouse. And I'll go ahead and record that transaction. So we've now actually created spaces in our model. In the next module, we'll look at tracking data on the spaces using the data group catalog system.
If you found this video helpful, please give it a like. If you want to see more such series, consider subscribing to our channel. Thank you, and see you next time.